Okay, so now we have this graph f of x equals 2x squared minus 8, and it says describe the domain and range. In order to do that, we want to graph this, but it's not in intercept form. And you can tell because intercept form, what we reviewed last time, has this f of x equals a times quantity of x minus p times x minus q. If you look at this very carefully and closely, it's nothing like that. It's f of x. There's not even two sets of parentheses here like this would have, nor is there a number in front. So it's not in intercept form. Guess we should all go home. Wait. Can we convert it to intercept form? Yes, we can. If you look carefully at these two terms, there's a greatest common factor that we can factor out. And what is the greatest common factor between a 2 and a negative 8? The GCF, the common factor would be a 2. So factor out the 2, and then what would you have left? You'd have an x squared minus 4. But wait, is this something we can factor? This is a square, this is a square, and there's a negative, so we can. This would be an x plus 2, x minus 2, if we use the difference of squares. Now, let's compare that to this. There's a 2, there's the x plus 2, the x minus p, the x minus 2, the x minus q. It's in the same form. Now, remember that in order to solve this, it's intercept form. And intercepts indicate that something equals 0. In this case, we're going to find the x-intercept. We're going to make this what would sometimes be considered the y equal to 0. Obviously, if this is the x, this would have to be the y, right? So then we have this 2 here. This 2 is equaling 0. But we know that 2 doesn't actually equal 0, so that's not true. But then we have an x plus 2 equaling 0 and an x minus 2 equaling 0. If x plus 2 equals 0, then x would be a negative 2. If x minus 2 equals 0, x would be a plus 2. So we know the answer for our p and our q. Okay. So if this is a 2, the p would be a negative 2. What's great about this is you're just taking the opposite number. If it's a 2, then it's a negative 2. And then if q is a negative 2, then q would be a 2. Okay, so what's the next step? The next step is to find the axis of symmetry. Now in intercept form, back to our notes from last class, we said the axis of symmetry is just x equals p plus q divided by 2. So p, well, let me just write it out because we're still looking at this. X equals p plus q divided by 2. Well, the p is a negative 2. Q is a 2. Well, that would just be 2 minus 2 would be 0. 0 over 2 would be 0. So the axis of symmetry this time is, well, it's kind of easy. It's just 0, right? So we have the axis of symmetry, and we also have the intercepts. So the intercepts here. Let's talk about that just to make sure that's understood. These are the intercepts, so that, remember, if x equals 0, I'm sorry, if y equals 0, the x would be a negative 2 for p. But if y equals 0, the q would be a 2. So we have our intercepts. All we did was take these numbers and put a 0 for the y. Kind of easy. Okay, now we need to graph this. Take the graph out here. So what are the numbers we're looking at? We're looking at our axis of symmetry being 0, right? Oh, I'm sorry, there's one more step. We found the axis of symmetry, and it's 0. But now we need to find the vertex. How do we find the vertex? We substitute a 0 now, and not for the y, but we substitute it in for the x. Whatever the answer is, the axis of symmetry, whatever the axis of symmetry is, you substitute it in for the x value, and that will give you the vertex. Let's do that. So I'm going to take this equation, f of x equals 2 times x plus 2, x minus 2. But instead of an x, when I rewrite it, I'm going to substitute a 0. So it's f of something equals 2 times the quantity of something plus 2 times something minus 2. And what are we putting in place of the x? 0. 0. And since there was more than one x, there's going to be more than one 0. Okay, let's see what that would be. 0 plus 2 is 2, and 2 times 2 is 4. 0 minus 2 is a negative 2. 4 times a negative 2, it's a negative 8. So our x value for the vertex was 0, our y value was a negative 8. Okay, so now we have our vertex, we have our intercepts. We can graph this very quickly. So the vertex was 0 and negative 8. Let's graph that. If x is 0, y is a negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And now we need the intercepts. We're just the opposite of these, right? So it's a negative 2 and a 2. Remember, the intercepts are going to go on this axis here, so it's a negative 2 and a positive 2. 1, 2. And we quickly have a parabola. All we needed was those 3 points. Okay, so I was explaining the steps, and I did this problem that probably could have been done pretty quickly, but I took my time and explained it all. But we could do another problem and show you how quickly it can be done. Let's look at this one right here. So again, first thing you want to make sure, though, is that it's an intercept form. This one's not. You can see there's not even 2 sets of parentheses. So let's get the 2 sets of parentheses by factoring out the greatest common factor. What goes into both of those terms? A 4. So you'd have then an x squared minus 9. And it's still not quite in this form. There's only 1 set of parentheses. But we can turn it into this form by factoring this. So we'd have x plus 3 times the quantity of x minus 3, because it's the difference of squares. This is a square, this is a square, and there's a negative. Okay. And then we set all of these equal to 0, and so then do the intercept, the x-intercepts, and so that we'd have p, remember, just do the opposite of this, equals negative 3. Q, do the opposite of this, equals a positive 3. Okay, then we find, so we have the intercepts, we should make clear on that. Intercept would be negative 3 comma 0, 3 comma 0. The intercepts are going to be that point on the x-axis where the parabola hits it. Okay, so we already have our 2 points. We just need to find that 1 point. We just need to find the vertex. And then we're done. So we're more than halfway done just by getting the intercepts. Okay. the x-intercepts, of course. Okay, let's find the vertex. So in order to find the vertex, we say p plus q, so negative 3 plus 3 divided by 2. In this case, it's going to be a 0 again. So the x is a 0. We just need to find the y. And how do we find the y? Is we substitute the vertex, we substitute the answer of the x, the axis of symmetry, into the equation again. So it's h of 0 equaling 4 times 0 plus 3 times 0 minus 3. So write those zeros in. So if the x is a 0, or the vertex, just substitute it in. Okay, so then we have 0 plus 3 is just 3, but 3 times 4 would be 12. 0 minus 3 would be a negative 3. This would be a negative 36. A negative 36. Oh, honestly, that's not going to be fun to graph at that point. So, but that would be the answer for it. You go down. Well, we could do it. We just won't count by. Let's just do it real quick. So our vertex is 0 and 36, but let's count by 6s each time. So this should be a negative 6, negative 12, negative 18, 24, negative 30, negative 36. There's your vertex, 0 and negative 36. 0 and negative 36, right? And then our intercepts would be a negative 3 and 0. So if we're counting by 6s, this would be a negative 6. So negative 3 would be halfway through that. And then this would be, the other one would be a 3 and 0. So again, it's halfway. And this is what the parabola would look like. All right, well, I hope that's helpful.